Hi guys, Buildzoid here, and today I'm going to be talking a bit more about the 12-volt high power connector. Not that I really want to, but I've seen a bunch of speculation out on the internet that, in my opinion, is not very grounded in, physics. So, yeah, I want to address some things. First of all, I've seen multiple people talking about arcing in this connector. Arcing is when you have a high enough voltage to jump an air gap from one object at one thing at high voltage to another thing at a much lower, at lower voltage, right? You can't get arcing with 12 volts. Okay, well, basically you can't get arcing with 12 volts. That's not to say that you can't get 12 volts to throw sparks. Yes, you can. But that's not arcing. That's usually, if you can get 12 volts to throw sparks by basically, sliding two conductors against each other, and if there's enough current flowing between them, and, as the connection intermittently goes good and bad, you're going to have, localized heating, and that's going to start spitting out sparks because, bits of the material are going to get extremely hot as the current is forced through a very small contact patch, and that's going to throw off sparks. Not arcing. Okay? Arcing is when electricity jumps an air gap. 12 volts is not enough to jump an air gap. Okay? So this isn't arcing. So, yeah. Anyway, another thing is, I'm pretty sure none of these connectors have actually gone through a fire. I know this looks really badly burnt, but this wouldn't, you can get plastic to look like this with just heat alone, because the thing is, once you get plastic, I don't know what exact plastic this connector is made of, but, let's just put it this way. When I do hot air soldering on boards and GPUs and that kind of thing, if the hot air gets near enough to the power connectors for long enough, yeah, they very quickly end up looking like this, even without any smoke or anything. If you just point they'll just melt, and past a certain temperature, the actual, plastic will chemically deteriorate into a, crusty, crumbly, disgusting mess that looks like this. You don't need fire for this. Same for this right here. This really looks like it might have caught fire, but I can tell you for a fact, if you get a PVC cable hot enough for long enough, it'll end up looking like this. It doesn't need to get to the point of actually being on fire. You just need to get it up to a high enough temperature that the PVC actually starts to, deteriorate chemically, and it'll create a crusty, crumbly mess like that. I speak from experience. There's been a few occasions where I tried to run entirely too much current through not enough wire. So, yeah. And this is the kind of thing you end up with when you try to push entirely too much current through not enough wire. Though in this case, this case right here, I don't think that's actually a too much current through not enough wire. This is heating causing the heat traveling up the wire and causing it to melt, because you can see how the connector's almost entirely gone in this area, because of how much it got melted. Anyway, so yeah, that's not to say that this isn't necessarily a fire hazard, but I don't think this is very likely to self-ignite, unless you put paper near it or something. So yeah. Anyway, another thing that I want to talk about is I've seen multiple people try to test if this connector is making a, good connection, with thermal cameras. And that doesn't, in my opinion, that can't really work because, I mean, the Founders Edition doesn't do this, but on most 4090s, there is airflow going over the connector. Plastic is not very thermally conductive. The part of the connector that's, overheating and melting is the inside of the connector, right? And if you look at how this connector is structured, you have a plastic shell around the terminal, and the terminal is the part that's actually getting really, really hot, and we can see that because, where's all of the damage localized to? To the terminals, right? This part of the connector, as you go further away from the pins, the connector actually looks almost perfectly fine. It's just at the pins that it's starting to melt. You also have connectors. Okay, that's the same one. You have this connector, right? Where is it melting? Oh, right at the pin. It's not melting further up the connector. It's melting right at the pin. The person who posted this photo literally didn't see anything wrong with this connector until they unplugged it and inspected it. right? So the heating starts at the pins because the pins don't make proper contact, there's too much resistance, current flowing through too much resistance is going to generate more heat than the connector can reliably dissipate. That is going to basically keep increasing the temperature of the connector until either you stop playing a game or something and then it'll cool back down again, or until it melts to the point that you notice it and turn off the system. Or I guess it melts to the point that a 12-volt contact manages to bridge to a ground contact, though I'm not entirely certain that that's physically possible. Yeah, what you might also end up with is that the connection gets so bad that the voltage on the GPU drops so low that the system shuts down. But anyway, yeah, and then we have like this one, and again, like this connector looks perfectly fine, except for the part where the pin is melting, right? Yeah, so I just wanted to point that. So basically, if you're pointing a thermal camera at this, you can't see anything because the terminal and the terminal is the part that gets hot. The terminal is encased in one layer of plastic, and then another layer of plastic, which is the actual outer casing of the connector on the GPU itself, right? So if you point a thermal camera at this, you're measuring the surface temperature of the plastic. If there's airflow going over the plastic, which is a thermal insulator, that plastic is just not going to be very hot. Like, plastic is such a good thermal insulator that I will regularly, like, when I'm doing, hot air soldering on a board, and the PCB is at, like, an insane temperature where you can't really, like, if you grab it, it'll instantly burn your fingers. I grab the card by the 8-pin power connectors, because it's plastic. It doesn't conduct heat very well, and so, it's not going to be at the same temperature as the rest of the board. The pins might be at the same temperature as the board, but the plastic itself is generally going to be way cooler than everything else, or at least not going to conduct that much heat. So if there's airflow over it, the surface temperature of the plastic is going to be very different from the internal temperature of the connector, right? So how could you try to measure whether or not this connector is overheating? My suggestion would be to basically try and measure the temperature of the metal pins themselves, but not the ones we can see here clearly in the photo, because these are actually the ground pins, and as you might have noticed, every single report of a melting 12-volt high-power connector is on the 12-volt side of the connector, except for the testing done by PCI SIG themselves, and the reasoning for this is very simple. PCI SIG probably used some kind of like actual test system, not a real GPU, and so they had equal load across both the 12-volt side and the ground side of the connector. In a real system, your PCIe slot is 50% ground, pretty much 50% ground. So in a real system, if there's not much load on your CPU or motherboard, a very, very large portion of the current going into your GPU is actually going to get back to the power supply through the motherboard. It's not going to go through the ground part of the 12-volt high power connector. So what you'll have is, say, you'll have like 40 amps flowing through the 12-volt side, and then on the ground side you'll have like 20 to 30 amps, because half the current is actually just going through the motherboard. That's perfectly normal. And that's also why it's always the 12-volt side of the connector that's melting. But that also means that you can't really, you can't measure the pins that we see up here, because those are ground pins. Those aren't 12-volt pins. The 12-volt pins are on the inside of the connector. So you could try to connect like thermocouples to every single one of the 12-volt pins on this side of the board. And yes, I know that will be incredibly physically difficult to do, probably maybe even impossible, but that is probably the best way you could try to measure what's happening to the internal temperature of the connector, because the metal pins are at least metal, and so they conduct a lot of heat very quickly, whereas the plastic isn't very thermally conductive. It's air-gapped from the part that's actually getting hot, and so, checking the surface temperature of the connector to figure out whether or not the inside is melting is kind of pointless, in my opinion. Especially if you have airflow in the environment, right? Like these tests from PCI SIG, like in these photos where they're showing these hotspots, like these are not connected to a GPU. So these are probably in a zero airflow environment, and so the cable, like the surface temperature of the cable, isn't being artificially reduced by the airflow in the area, which is also probably another reason why, like, this connector is trashed, right up until you get outside, like into, to the part of the connector where you actually start getting airflow, right? Like this part, these surfaces right here, those are not, like those are actually exposed to like direct air. They're not encased in the plastic of the connector. You can kind of see the same thing going on here. Like this almost looks okay, except for the internal parts, right? Like the outer surface really looks a lot better than the inner portion of the connector because the heat starts inside the connector and plastic is not very thermally conductive. And if you have airflow, which like literally there's a heat sink over here, there's airflow going through over the connector, like the outer surface of the connector is going to be way cooler than the inside of it, potentially. I mean, well, in this case, definitely way cooler because it literally melted. So yeah, pointing a thermal camera at this connector and trying to see if it's gonna melt on a real GPU probably isn't gonna work. Because it's not gonna work until the point that the connector actually starts to melt. Because like it's plastic. It's just not that thermally conductive. So you could maybe try to measure the temperature of the actual pins. Now the pins are also being sunk into the 12-volt planes of the actual PCB, so those might still not be quite at the same temperature as the inside of the connector, but you could potentially see like a temperature difference between the pin over here and the middle pins and the outer pins. Like you might actually get like a temperature difference between the pins, which would be indicative of like a imbalanced imbalanced loading of the pins inside the connector. Though I don't know how well this would work in practice. I don't have a 4090. I don't have one of these connectors. I did actually look into maybe buying one of these NVIDIA adapters, but turns out they don't really seem to sell them. So anyway, yeah, like you could basically try to attach thermocouples to the pins. That's probably the closest you could get to an internal connector temperature measurement. Don't try to like shove, well, I mean, you can't even shove thermal sensors down this connector because of how it's structured. Like, yeah, good luck shoving temperature sensors into this thing. I've seen a lot of people put blame onto the solder joints, which to me seems insane considering like, oh, I don't know, where are the solder joints in this photo? On the other end of the connector, which isn't melting. It's melting here in the pins. Same goes for this one. Like, this thing's completely destroyed on the pin side of the connector, and the solder joints are, like, way out here. Yeah, I don't... Like, those aren't melting. So, like, yes, this looks really bad, but the soldering, and maybe the soldering... Like, maybe that would fail as well if you, bent the connector back and forth enough times in the future. But, like, this side of the connector wouldn't cause this kind of damage. Like, the damage would start over here, not there, right? Like, it's not, yeah. Anyway, so that's another thing I want to point out. I've been made aware of the fact that NVIDIA is using really cheap, crappy pins inside their adapter, which would maybe explain why so far every single report of melting that we've seen seems to be related to the NVIDIA adapter. And basically, the terminals that NVIDIA is using have 2 splits in them instead of a single split in them, which means that, the terminal has pretty much no horizontal structural integrity whatsoever because there's literally no material in the horizontal direction holding it together. I mean, exactly the kind of thing you expect from an adapter cable for your $1,600 GPU. And I'm actually serious about that. Like, high-end NVIDIA GPUs having garbage tier build quality is the norm, not the exception. There are many NVIDIA GPUs where I'm confused as to how they still function. But yeah, here we have some photos. Oh, look, yes, like this is an NVIDIA adapter, as you can clearly see. And yeah, there's 2 splits in these pins. I wonder why it would be so susceptible to horizontal bending. And the thing is, like, basically, because you have this, like, 2-split, terminal, you could, in theory, basically bend the terminal to the point that one of the sides just doesn't make any contact with the pin whatsoever. Because, like, there's nothing holding it together. Literally nothing. There's 2 splits in the freaking in the terminal. And so then your contact resistance, like if one of these blades isn't, making contact, well, your resistance is going to be at least double what it's supposed to be, probably more than that. And then the connector is gonna then that part of the connector is gonna produce excess amounts of heat and eventually melt. And this will take forever because this is a relatively low resistance connection. It's not really it won't really generate a lot of heat unless the connection is really, really, really bad. And also, there's probably a bit of a thermal runaway effect where at some point the temperature of the connector itself, like of the terminal, is so high that it starts significantly increasing its resistance, which further increases the rate of heating. So basically, like the connector could be fine, and then it hits a critical temperature where it starts to thermally run away and very quickly goes from, fine to looking like this. And so that's another thing. I guess it's also worth pointing out that because the heat the damage starts inside the connector, you can have cards that look perfectly fine until you unplug the connector and inspect it. That would be the case of this card right here. Where is it? This is a new one. So 1 week after installing the card, I read about this problem this morning, so I inspected my connector, and voila, yeah, just localized damage to the inside of the connector, because we've got crappy pins that don't, or it's not even, these aren't the pins, it's the terminal. We've got crappy terminals that have 2 splits in them, and no horizontal, rigidity whatsoever, because, yeah. To be fair, they are, you can see that there's, little plastic protrusions that are supposed to hold the metal part together, but plastic's not exactly strong, so, if you bend it horizontally, yeah, you're probably going to just leverage the terminal open, and then the terminal's not going to, the terminals are going to have way more resistance than they're supposed to, and it's going to generate a bunch of heat. Anyway, so yeah, pointing a thermal camera at this connector and observing the fact that the circuit fist temperature of the connector is basically the same as the temperature of the air being exhausted from the heatsink of the GPU, kind of pointless, okay? That doesn't really seem like a viable way of doing testing on this. Alternatively, instead of trying to measure the temperature, what I would try to do, because this would be less susceptible to, issues with the thermal conductivity of the everything, right? Because, the thermal conductivity of the pins, the PCB, the plastics, it's really hard to get an internal temperature measurement, and you can't just shove a probe inside the connector because that'll potentially screw up the contact. So, yeah, that's not really an option. Instead, what I would try to do is actually measure the voltage drop across the connector. Thanks to NVIDIA's interesting design of this connector, you should be able to measure basically any one of the pads on this side of the connector. And it'll give you a pretty close voltage for this, for the PSU side of the for the connector. And then you can measure the voltage on the card while it's running on these pins over here. This top row. Those are the 12-volt pins. And basically, if the voltage on these pins is way lower than the voltage on this side of the connector, you know that there's a problem because there is excessive amounts of heat being dissipated inside the connector. Now, what would be an excessive amount of voltage drop? Well, at least in theory, if we go by the spec of the connector, it's supposed to have 6 milliohms of resistance per contact. So, we've got 6 contacts on the 12-volt side of the connector. We go 0.006, we divide that by 6, so we should have about 1 milliohm of resistance. So if we're shoving 40 amps through the connector, we should see a 0.04 volt drop across the connector, assuming that the connector is working correctly at with a 40 amp load. So that would be 12 volts. So let's say we have, and the thing is, you need to keep in mind that the cables themselves will have some voltage drop across them, but we're just going to pretend that there's going to be a 12 volts on this side of the connector for convenience. It might be 11.9, it might be 11.9, whatever voltage you have on this side of the connector. So we're going to, for convenience, say it's 12 volts. We're going to subtract our 0.04 volts, and on the other side of the connector, you should basically see 11.96 volts if there's 12 volts on the power supply side of the connector. So on the GPU side, you should see 11.96 volts. And this would mean that the connector is dissipating 1.6 watts of heat in the 12 volt side of the connection. And this is normal. Like, the connector is, expected to dissipate some amount of heat. And the connector is rated for quite high operating temperatures, right? Up to 105 degrees Celsius, 30 Celsius terminal temperature rise at rated current, which I'm not sure if that's supposed to be internal temperatures at 135. That's the way I'm reading it, but 135 degrees Celsius should not be causing the plastic to melt, okay? So, yeah. Anyway, so basically what you could do is, install the connector, optimally, measure the voltage drop, and then you could bend the connector and measure the voltage drop, and then bend it again and measure the voltage drop. At some point, there's going to be a bend that's going to cause, excessive amounts of voltage drop, and once you've achieved that, if you want to test if it'll melt the connector, you can just keep it running like that for several hours, and you might end up with something that looks like this eventually, or something that looks a bit like this, right? And that's kind of the thing. Yeah, this is a really awkward thing to try diagnose ahead of time, because connectors have very low resistance, so measuring the resistance of the connection is very difficult. Also, because of the way this connector is structured, you can't actually test the resistance of each individual pin. You can only test the average resistance of the entire connector, right? Because this is just a bunch of resistors in parallel, and so you can't really isolate them from each other. Not without destroying the adapter, at which point you've just invalidated your testing, because that's not how the freaking adapter is built. Yeah, I would try to basically measure the voltage drop across the connector. There's going to be a certain level of voltage drop across the connector that's entirely excessive, and that'll cause the connector to eventually melt. Now, the one downside to trying to measure the voltage drop across the connector is it might not if you have really good contact on most of the pins and there's just one contact that's really bad, you won't necessarily be able to measure a very high voltage drop in that scenario. But then again, if you have good enough resistance, in theory, the current should just go through the other part of the connector. Because this is parallel resistors. So the current, the distribution of current through the connector will actually change depending on how good the contact between all of the how good the contact of each pin is. And I keep saying pin, even though it's evidently the terminals that are melting, but well, the terminals are making contact with the pins, so yeah. Anyway, so yeah, I would try to measure the voltage drop. It really looks like, especially the NVIDIA adapter, just sucks because, $1,600 GPU with NVIDIA build quality. I mean, what did you expect? Because yeah, this, you can see it's two splits in each of the wires. For comparison, here's some Corsair and cable mod cables, and here the Corsair one, you can very clearly see they have one split in this. So obviously these pins are much more horizontally robust than NVIDIA's pins. And then if we look at the cable mod ones, yeah, same kind of deal. You have a very clear notch over here and not really anything in the other side of the connector. And then there's the NVIDIA ones where it's just yep, there's a notch there and a notch on the bottom edge, or actually this pin's the best one to see that with. So, yeah, it does look like it might be limited to NVIDIA's own adapter. But the last thing I want to say is I still think this connector is freaking stupid, because it just has less safety margin than our good old 8-pin power connectors, right? So here's the Molex specifications for the PCIe 8-pin power connectors, and that's not to say that people haven't managed to melt 8-pin power connectors. They absolutely have. It's just that, not really that common, considering how long we've had 8-pin power connectors. And yeah. Anyway, so the spec for an 8-pin power connector, and I'll put it this way, if your power supply has 20 gauge cables for your PCIe connectors, you should throw that power supply out because it sucks. Like, just straight up, your power supply sucks, get rid of it. So assuming you have a good power supply or a great power supply, you should have like 16 gauge or 18 gauge cables for all of your high current connectors, like your PCIe 8-pin, 6-pin, EPS 8-volt, EPS 12-volt for your motherboard, that kind of thing. Anyway, so 8.5 amps per contact. They're in an 8-pin power connector. You've got 3 12 volts, 3 grounds. So we're going to do 8.5 times 3. And basically, an 8-pin power connector is supposed to handle like 25.5 amps with the same temperature considerations as what the Amphenol, high power connector is supposed to handle as well. So, like, this is rated from -40 to plus 105. This is rated from -40 and 100 up to 105. It's almost like there's standards for these kinds of things. But anyway, so yeah, the 8-pin can do 25.5 amps, which if you multiply that by 12 volts, that's 306 watts. The 8-pin power connector is generally treated as a 150 watt power connector. The only exception to this is the R9 295X2, where AMD decided to use basically the entire current handling capability of the 8-pin power connector. Because an R9 295X2 is a 500 watt GPU and it only has 2 8-pins, which also not the greatest idea I've ever seen, but somehow I don't think we've seen as many melted connectors for 295X2s as we've seen for 4090s, though that could be related to the fact that probably 295X2s are very rare compared to 4090s. Anyway, so like your standard 8-pin power connector has like 100% safety margin. And even if you have a garbage tier power supply, you still have an almost 100% safety margin. Like, the connector is rated for normal, like, it's not really rated for, it's rated for 250, but it's used as a 150 watt connector. So there's like a 100 watt safety margin. For comparison, the 12 volt high power connector is expected to do 600 watts and is rated up to 9.5 amps per contact, assuming that they're all making perfect contact, which, they don't tend to do because they keep melting. At least when you use the NVIDIA adapter. Which is probably because of the split terminals that NVIDIA is using. But anyway, so 9.5 amps times 6, and we're just taking the 12 volt side of the connector every time, and you multiply that by 12 volts. Oh, look, 684 watts. So there's like a, 14% safety margin on this connector compared to the 252 divided by 150 that you get on a 8-pin, which is a 68% safety margin. And that's assuming you have a garbage tier power supply. If you have a good power supply, the safety margin is, 306, divided by 150. Nope, that's the wrong one. I have several calculators open. Divided by 150, you have like 104% safety margin on the regular 8-pin power connector. So, also, if you had 3 8-pin power connectors, they are capable of, 306 times 3, 918 watts. So, the thing that, like, I get a kick out of is, like, this is like 1,000 watts of power connectors on this end, and then it goes into 600 watts of power connector on the other end. Yeah, that's great. That's truly amazing. Like, to be fair, the reason why NVIDIA puts 4 8-pins on this is so that, like, you're not supposed to do what AMD did with the 295X2, where it's like, well, the two 8-pins are actually able to handle a lot more than we normally say they do. So, like, the reason there's 4 of them is because NVIDIA is treating the 8-pins as 150 watt connectors. But, like, right now, it really does seem that the main cause of all of the melting adapters is NVIDIA's garbage tier decision to use double split terminals, which just don't have any horizontal structural integrity whatsoever, because there's 2 splits in them. But even then, this is just a worse connector than having 3 separate 8 pins. Like, yeah, like I'd much rather have 3 separate 8 pins than this thing. And also, if you're wondering, and another thing is, as far as I know, NVIDIA is straight up forcing all of their add-in board partners to use this power connector, which I think is really stupid, because I'd much rather have a 4090 with 3 8 pins than this abomination. Like, if NVIDIA wants to use it on their Founders Edition PCB because for some reason the PCB needs to be this shape, that's totally cool. I don't really like buying NVIDIA reference cards anyway, or like I don't generally like things like NVIDIA designed PCBs. So reference cards, Founders Editions, like, to be fair, there's nothing really wrong with this, but I don't like that connector. And I didn't like that connector ever since it got first introduced. And the thing is, on a 3080, 3090, that connector only has to deal with like 300 watts. Another sort of interesting thing that I've noticed is if you look at a 4090 implementation of the connector versus a 3090 Ti, a 3090 Ti actually treats this connector as 3 separate power connectors. You can kind of see it from the fact that we have these 3 shunt resistors and like 3 12-volt polygons going to the connector. Like, this is basically being treated as 3 separate, like, 4-pin connectors in one. Whereas what you have on a 4090 is being treated as one giant 12-volt connector. And yes, I know there's 2 shunts, but those 2 shunts actually are connected to the same 12-volt power plane. They're just putting the shunts in parallel to reduce the amount of heat that each of those shunt resistors is producing. So, yeah, like, NVIDIA's, like, so that might explain why 3090 Ti's didn't really have issues with it, because they, like, 3090 Ti's are actually kind of trying to load balance 3 sectors of the connector, whereas a 4090 is just kind of like, doesn't. I don't know if that's actually the 3090 Ti is definitely load balancing the connector across like 3 sectors, whereas a 4090 definitely isn't doing that. That could be related to the melting power connectors, though I don't see how. Like, I've tried to think about, like, why would balancing the current across the connector somewhat like make the pins less likely to melt. I am not really seeing why that would work. Because if you have one pin that isn't making proper contact in one of the, like, 3 sectors that a 3090 Ti sees the power connector as, like, that pin still isn't making proper contact, and it's still going to try to pull, like, 150 watts through that sector anyway, right? So you're going to have, what, theoretically, that pin should still be able to melt. It's just, yeah. So, not entirely sure why it seems to be, like, especially common with 4090s that this connector is melting. It might be because 4090s are just more popular than 3090 Ti's, and so people have been getting more creative with how they bend the NVIDIA power adapter, and the adapter's giving up. Or they maybe change the manufacturing of the adapter between the 3090 Ti and the 4090. That's also a possibility, but yeah, I don't know. Actually, what adapter did the 3090 Ti use? Because now that I say that, like, it didn't use the same 4-pin thing, did it? Oh, we don't have a picture of the power connect adapter. Yeah, but I'm pretty sure this thing had a different adapter from the 4090. Oh, wait, this had wait. Oh, on the 30... Wait, no, that's a 3090, not a 3090 Ti. Yeah, so that had 3 8 pins, like a reasonably designed GPU should. Do they show the adapter? No. Damn it. I'm pretty sure 3090 Ti's had a different adapter, though. So maybe those were actually using, like, proper pins, proper terminals instead of the 2 split ones that you have now on the 4090s. But yeah, anyway, so that's kind of my thoughts on this. Like, this connector still is worse than 3 separate 8 pins. Though it really seems like every single case of melting right now is due to NVIDIA's NVIDIA's adapter, which is probably because the pins have two splits in them, which means absolutely no horizontal structural rigidity whatsoever. And I guess if you just wobble the connector around for long enough, like you'll just spread the terminals right open. And once you do that, like the connector is liable to sort of start melting from the inside. So yeah. And pointing a thermal camera at the surface of the power connector isn't going to tell you anything. So anyway, yeah, like at this point, like I would not use the NVIDIA adapter. I would definitely not let one of these leave one of these cards rendering overnight or something with the adapter installed. Like, it shouldn't really cause a fire because I don't think the plastic is like particularly flammable. But yeah, if you don't want your power connector melting, you should probably you could also lower the power limit on the GPU a bunch down to like 250 watts or something. So even if the connector isn't making proper contact, like you're just not going to have that much heat dissipation in it. Yeah, this could have all been avoided if NVIDIA didn't, need a fancy new connector for their overly complicated GPU designs. I still don't get why this connector exists. Like, I really don't. Like, 3 8-pins are just better than this. Like, yes, they're not rated for 600 watts, but have you ever heard, like, R9 290Xs, when overclocked, would pull 400 watts and up on an 8+6-pin power connector configuration. Actually, high-end GPUs historically have a lot of historical high-end GPUs, when overclocked, would massively overload their power connectors, and it was fine, because there was this monstrous safety margin built into them. Right? Like, literally, the connector was, like, rated for half of what it can actually take. And so even when you were overclocking GPUs that would regularly go from, 250 watts, 300 watts, all the way up to, like, 400, 500 watts, it was fine. Like, a 290X, when overclocked, can easily do 400, 450 watts on an 8+6 pin. So, yeah, like, that's not saying that it's okay to ship a 8+6 pin card with a 450 watt power limit. It's not. Don't do that. But, like, yeah, like, the 12 volt high power connector, as far as I'm concerned, is just a downgrade from 3 separate 8 pins. Because it is, literally. Like, the spec even tells you that. It's just worse. But it really looks like the melting that we're seeing right now seems to be more related to the fact that NVIDIA used the absolute cheapest terminals that they could get their hands on. Which is the most NVIDIA thing ever. Anyway, that's it for the video. Goodbye.